Okay, we're going to be looking at the SVT Classic 300 water. This amp has 6 of the 6550 tubes and is very heavy and has a protection circuit built in that will go into a protection mode if either of the bias values I guess I should back up. There's 6 tubes in a push-pull configuration, so there's 3 power tubes on each side. And if the bias is off from what it wants to see for any of those tubes, so that one side is pulling too much or too little current for the bias, it'll go into a protection mode. So your tolerance for very expensive tubes has to be very tight in terms of your bias. Not only that, but there are resistors that are in that sensor circuit, which often need to be replaced because those resistors can drift out of tolerance, which then makes the problem even worse. You could have totally good tubes and still get thrown into that protection circuit or part of the circuit. When that protection happens, it cuts out the amp. So these are great sounding amps. They can be very problematic. When you also add into that the fact that to replace like a screen resistor, you have to pull this chassis out, which takes anywhere from 30 to 40 minutes and weighs about 80 pounds between the upper and lower chassis, which you have to finagle through here to get out. Not fun to work on. This is the amp that most techs, at least that I know, will not even work on anymore. This one belongs to a buddy, so I'm going to work on it for him. But I don't usually like getting these in the shop, although I'm still willing to do it. But yeah, every time I work on one of these amplifiers, it's a good reminder to get in the gym and lift some weights, because got to stay healthy. If you're working on some guitar amps, got to be able to lift these things up. Okay, so we're going to dive into this. This one's getting thrown into the protection mode. Hopefully it's just tubes. I'm going to show a way to test that out with just a bias probe to try to match things up. We can also test for the blown screen resistor from the tube sockets. And assuming all the screen resistors are good and the tubes, just either one's faulted out and can be replaced with something I have on hand, or they just need to be rearranged in their configuration to get the bias a little bit closer between the two sides of the push-pull, we won't have to open this amp up. That's what I'm hoping. If we do have to open it up, it's a good opportunity to show people how to do that step by step, but let's hope that it doesn't come to that. All right, let's dive in. Okay, we've got the back of the amp opened up here. I can see we need to clean out some dust, stuff like that first. Looks like we're also missing a nut for this one bias control, so I'll get that back on, or put a extra one on there. If I have one for the slave out, also make sure that those are nice and secure, so we're not going to break any solder joints from where those are attached to the panel. So the process, the way this is going to work, so these tubes are in 2 sets. So these 3, looking at the back of the amp, are one set. These 3 are another. And then we have bias controls for each of those 2 sets that we can individually set up. So one of the best ways to do this is to pull all the tubes, label them with what their position is. You can call it whatever you want, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. It doesn't matter. We just need to keep track of the configuration the tubes were in as they came out of the amp. And then since these 2 are nice and accessible and are from either side, we can put tubes into these sockets 2 at a time. Since it's a push-pull amp, it just wants at least one tube on either side of that to have a balance of the push and the pull. We can then check the current that's being pulled from each of those tubes, label it, and do that for all 6 tubes, so that we then are able to create a situation where we have balance in bias current being pulled from each of the two sets. That's what this is looking for. Okay, so the other thing, though, that can throw the protection circuit, I think one of these is a 12AT7. I'm going to have to double check. And I believe if that is out, it will also throw under protection mode. So I might just try that first after cleaning some of the dust up in here. See if that fixes the issue, because that's a little bit less time consuming. But we'll see where we go next with this. I'll probably try that first. And if swapping out the preamp tubes doesn't do anything for us, then we'll dive into checking the current on each of these and moving forward from there. So we've got our power tubes pulled. I've already tested on the tube tester. These, I missed it before, but these are labeled down here. You can mostly see these two are 12 AU7s, not AT7s, and then 12 AX7. These are all testing good. One of them, this guy, I believe, was right on the low side of the good, but none are failed. So I don't think that's going to be the issue. I've got a chart ready to go here just to record the currents, make sure I'm keeping everything straight. And then the tubes are labeled as I pulled them out, so I know, just with some painter's tape and a Sharpie, labeled 1 through 6 so that I can put them back in the original arrangement or know what the idle current was for each side, see if that's potentially an issue. Right now, I want to, before I do that test, make sure there's no blown screen resistors. We can do this with just through the tube sockets. However, in order to take an accurate resistance reading, we need to make sure there's no voltage. And you can see right there, there is voltage still slowly dissipating from the filter caps. So I think we can actually, since that is a low voltage, it's something around 10 volts. If that were like 200 volts or something like that, we wouldn't want to do this. But since that is so low, we can probably just switch over to a current mode on our meter to dissipate that. Let's see if that will work for us. So between those 2 points, we're now doing DC current, and it is going to slowly go down. We know we're doing milliamps, and I pressed the yellow button here to go to the option that's DC, and then swapped my probe. This is a great way to discharge current because you're going through the fuse of the meter. So we're down to a pretty low value. Let's see if we have any voltage left there. Okay, we've dissipated pretty much any effective voltage. So now I'm going to go through and do resistance checks to make sure that there are the screen resistors. None of them are failed open. Okay, to illustrate how I'm doing this test, by looking at a schematic, you can see our power tubes here. And basically what I'm going to do is test from pin 5 of one tube to pin 5 of another, and we should be able to, we should see both those resistances in series from one to the other. So it should be double that 47K value, about 90 something K. And I'll have to do 2 tests per each of our side of 3 tubes. So test from here to there to see that that's the case, and then from here potentially to this tube. Sorry, we're getting out of focus there. But any combination of 2 to verify all 3 of those resistors, and then same for the second set. So if these 3 are a set, we can go between pin 5 of each of those and see we've got 93K, so that's good. And then move over to the other side, 93K. And now I'll do the same for the other side for these 3. And that'll verify that those 47K resistors have not blown just from a tube transient or something like that. And we can do the same off pin 4 for our 22 ohm resistors here. Yeah, just checks we can do to make sure that there's nothing wrong with this circuit without having to go to the trouble of pulling the entire chassis and checking that on the board. Okay, and same deal here, but with pin 4 of these tube sockets. It's hard to see the black probe back there, but you can see we're getting 438 ohms. 438 ohms. I think this schematic that we're looking at here is an old version from before a service bulletin. I believe these are 220 ohm resistors, which is why we're getting the 440-ish ohms between those 2 points. We're going to, this is what I was talking about, we're basically taking, so this is what I'm calling tube 1, which is one of the tubes from this pair, or this set of 3. This is what I'm calling tube 4 from this set. We're putting into a single tube socket from each of the 2 sides. So we still have our push-pull. The amp will be happy. It'll be operating at a third of the wattage. And then we're going to let this thing warm up and then measure the idle current and record that for each of these tubes. And do that for all 6 tubes so that we can then see what our current is and for at rest for each of these tubes to try to create matches that will keep the amp nice and happy. So I'll fire this thing up and we'll see what these are sitting at, and then we'll move through the other 2 pairs that we have. Okay, so just for an example, these 2 tubes have been heating up for a little bit, and at idle, they're both pulling exactly the same, 17 milliamps. So this is great news for these 2 tubes. This is potentially bad news for me because it means maybe we need to open up this chassis and see if there's a bigger issue. But we're going to move through the other 2 sets of 2 and record these values for tube 1 and tube 4. And then I'll report back after I've done all 6 tubes and we'll move on from there. So here's where we landed with the idle currents of the tubes to see if they are matched between this set and this other set over here. What we're looking for is a total current draw between these 3 tubes to be as close as possible to these so that the bias protection circuit is nice and happy. Now, there is a slight, this is actually very close and closer than I was expecting, which is good news for the customer because the set of these tubes is about $300 just for the power tubes. But yeah, so 17, 17, and 15 milliamps for one side, which adds up to a current of 49 milliamps. And then for the other side, 17, 16, and 16, which is 49 milliamps. So it doesn't get much closer than that. It doesn't matter that like this one's a 15 and that's 16 and 16. What we're really looking for, like if one of these was way low, if this was like 10, and then this one was also 9 or 10, that would still get us the similar offset between the 2 sides. That's all we're looking for. So this means I actually still haven't gotten this thing to throw into protection mode like it was doing for the customer, which means could be a vibration related issue, something where when it's sitting on top of their 8x10 cab, something is rattling loose, maybe a connection point on one of the harnesses. So I may need to actually fire this thing up and get pretty loud to try to simulate that. That'll be my next step before actually opening up the amp. In case you can't tell if I haven't made this clear, I'm trying to avoid actually pulling the harness or pulling the chassis on this thing. But if I do have to, we'll do it. I'll show you how to do that. It'll be a good learning experience for everybody. Okay, so stay tuned. We'll see what happens next. Okay, it's looking like we are going to pull the chassis for this SVT Classic. I'm going to actually make that into a separate video that is just instructions on how to pull the chassis because it is a little bit involved. So if I can figure out how to do that, that'll be linked somewhere down below here. And then we'll pick up from that point for this video for troubleshooting. And go from there. Okay, so we have our main board freed. The way to do that is to remove the nuts for these 2, this guy, and these 2 jacks. We also have to remove 2 screws from this transformer balance out, which connect to that XLR style connector there. We then have to remove 3 screws. There's one here, here, and here. And there may be zip ties holding cables to the board when you're doing this. If the amp has never been serviced, then you have to pull at the very minimum these 2 plugs from this side. And then also there's one that connects to this connector, which there's a short connector there. Otherwise you won't be able to lift the board up. And then also watch out for the washers that connect to the bias control. There'll be a couple lock washers there. Okay, so we're going to flip this board over. I already saw an issue, but I want to show you guys what's going on here. All right, so we've got our power tube board here below. I'll probably pull this just to see if there's any issues with the... I'll probably pull this just to see if there's any issues with the screen resistors or anything like that as well, since we're in here. But we do have a much bigger problem, which is this guy right here. You can see this domed top. That is a bad capacitor that is on its way out. So I've actually never done a cap job on one of these amps. It should be pretty straightforward in some ways since everything is right here. However, we are going to have to deal with getting all that glue or epoxy or whatever it is out of the way. And also, if that cap is going bad, there's a good chance that all the rest are on their way out too, which means we might need to do all of these. So I'm going to have to throw this back to the customer to see what they want to do. One other note while we're in here, these resistors here, I believe it's these and then also these 2. I could be mistaken about these guys. But those are the resistors that are used for the current sensing that's used for the bias control in these amps. So if you have one of these that's being really finicky, there's a decent chance, or it's at least worth checking to see if these resistors are measuring within 1% of each other. Because if the resistors that were in place here, the ones that were used stock, were not 1% resistors, and they tend to drift in their value. And that contributes to any errors that are sensed at the bias sensing circuit, which can then cause you to think that you need a new set of $300 tubes prematurely. So worth getting in there, checking that out if you're handy, or if you have a tech that's going in to investigate, see if they are willing to check that out for you. Okay, so that could easily be contributing to our issue, and if not, should be addressed anyway. I'm going to take a look at this other board. I think I can actually look at this one from the top side. There's a panel that will come off. So I may see about doing that instead of actually pulling this board from the underside, but I'll take a closer look and report back. All right, so just heard back from the customer on this one, and we are going to be replacing all of the filter caps there. So unfortunately, this is going to be a part 1 video of a longer series to get this up and running. But on the bright side, I'm going to show you guys how to do a cap job on an SVT. Things of note. So when I was ordering the capacitors for this, you want to make sure that you're getting the correct microfarads and voltage. Again, always making sure you're getting at least the rated voltage for the capacitor. The microfarads, you want to get, these are all common values, so it wasn't an issue. But if, like, for some reason we could only get like an 80 microfarad instead of 100, that wouldn't be a huge deal on this. But if we were to drop this down from 450 to 400, that would be a problem that this cap could blow. But we're going to be doing the full set here. You always, similar to changing your tires on a all-wheel drive vehicle, we want to change filter caps altogether. Yeah, and moving forward, hopefully that will be here within about a week, and then we can, oh, sorry, the other thing I was going to mention, for something like this, we want to make sure, because these are board-mounted capacitors, it's very important to take note of the diameter, so the width of the capacitor as well as the height, to make sure everything's going to fit correctly. But then we also want to, if we flip this board over, take consideration of what's called the lead spacing. So the space between the leads, the legs of these capacitors. If we get ones that are too wide or too narrow for something like this, where the capacitors are sitting right against the board, we're going to end up with a janky situation where they're not going to be able to go like directly against the circuit board the way it's designed. So we want to avoid that wherever possible. Make sure we're doing a good job. And as long as everything's discharged, you can just do that with a ruler to try to figure out the proper lead spacing is what that's called. And you can usually sort by that value on places like DigiKey or Mouser when you're looking for capacitors. So yeah, we'll be back soon, hopefully in the next week or so, with an update on this guy. Sorry, I don't know why we're going out of focus so much. Okay, and as soon as I can get this open back up to take a look with the new parts, we will dive into the SVT further. Thanks for watching. Hope you're having a good evening.